For many years, the allele that confers resistance to powdery mildew, a fungus that is very prevalent in wheat and other crops, has been investigated by Dr. Beat Keller.
This plant here has been infected with powdery mildew, which causes a white, fuzzy growth to appear on the leaves. This plant has not been infected and is healthy.
The allele that we are talking about is PM3. There happens to be multiple different resistant alleles, but the one that we are focusing on is the PM3 one. It is on chromosome 1, and it happens to also be on the short arm, which is the P arm. The reason why this is so important to know is because only one copy of PM3 is resistant to powdery mildew, but the more copies that you have, the greater resistance.
After conducting trials at the University of Zurich, it became obvious that multiple genes would be needed to convey resistance. Thus, gene pyramiding or layering was implemented. This was done by cross-breeding variations of the PM3 allele together to create a new cross. To make a cross, a plant must first be emasculated.
Emasculation is the removal of the male reproductive organs, or anthers, that contain pollen. The first step in emasculation is to cut the glumes, which house the anthers. The next step is to open the glumes using tweezers to gain access to the anthers. You must do this to all spikelets on the wheat head. Once the anthers are successfully removed, you are ready for the next step in crossing. You must take your male and female heads and wrap them in a bag so that the male is able to successfully fertilize the ovules of the female plant without contamination from other males. In return, these parental lines create 4 new wheat lines that contain 2 different variations of the PM3 allele.
After this experiment, Dr. Keller noticed that these 2 lines that he had created had an increase in resistance to powdery mildew. Now we're going to demonstrate how this can be naturally done through crossbreeding. Just like how she demonstrated with the emasculation, I'm going to show you through a demonstration with little squares and how you could still have the naturally occurring plant with the allele even if it didn't have it originally. The blue squares are the ones that don't have the PM3 allele, so they are not resistant to powdery mildew, while the pink squares happen to have the PM3 allele, which makes them resistant to powdery mildew. Naturally, in the wild, these 2 might cross, and first off, they would produce their own offspring, and then these offsprings would breed together to get a one that's half the non-resistant one and resistant one. But what you want will be the blue one, which is the bob white wheat, which is the one that they used to create the study with. So in order to get a wheat that's inherently bob white with the PM3 allele, you would back cross it. So you would breed it back to either the parent, grandparent, and then get another one that's still like a quarter of the resistant one but has the bob white traits. And then you would breed this one back to get another offspring. And then you just keep back crossing until you get one that is mostly bob white but has the PM3 allele. And this might take multiple generations, and this is how it would probably naturally occur in the wild. And so what you get as your final product is just a bob white that has the PM3 allele and is now resistant to powdery mildew. Of course, you'll want more than just one resistant allele, because the more you have, the more resistant to powdery mildew it is. Because even powdery mildew can overcome this resistance. And so maybe in the future this plant breeds back to another pink one, and it just builds up the PM3 allele, because what you'll want is multiple copies of the PM3
The
allele.
PM3 allele triggers a hypersensitive response in the plant. This response causes the plant cell to die as soon as the harmful fungus attempts to inject the AVR PM3 protein into the plant cell. This protein is the virulence protein that allows this fungus to attack its host plant. Essentially, the hypersensitive response punches out the powdery mildew so it cannot harm the wheat farther.
One of the ways that they did this to input the PM3 allele other than crossbreeding was using transgenics, which was using a genetic engineering method to just take the PM3 allele and just input it into the bob white plant. So that they had a plant that was completely bob white in every shape and form, but still had the PM3 allele.